Pythagorean theorem. Say we have a right angle triangle. Here. The Pythagorean theorem states that a squared plus b squared is c squared. A squared plus b. When one leg of the triangle is a, the other leg is b, and the hypotenuse is c. This is a very famous theorem and it's very useful when we're talking about right angle triangles. Okay? But let me show you a quick way of proving this theorem. Say we have, sorry, that has to be squared. Say we have these 4 right angle triangles. I'm going to rotate them. Okay. Now, I've just got 4 of these right angle triangles right here. But I've just rotated them 90 degrees each time. Okay? So if I put on the sides, I've got this is A, this is B, this is B, this is A, this is B, this is A, this is B, and this is A. Okay? And just according to the labeling, this is C, this is C, this is C, this is C. Okay. So if I wanted to find the blue area in the middle, okay, I could just write the blue area is equal to C squared, right? Okay, because it's clearly a square, because all the 4 sides are C and they form 90 degrees right here. So the blue area is C squared. However, we can also represent the blue area in another way. Okay, is equal to, so the blue area could also be equal to the entire grid, right, minus the area of the 4 triangles. So the entire big square minus the area of these 4 triangles leaves us with just the area of the blue. So let's do that. So we're doing the entire grid is a plus b squared. So a plus b squared. And then we're minusing the area of these 4 triangles. Now, what is the area of a triangle? Half base times height. So area of one triangle is half AB. However, since we have 4 of them, we want to times it by 4. So this is equal to 2AB. And we have to subtract the area of these 4 triangles in order to get c squared, the area of the blue. So minus 2AB. Okay? Now let's expand this. A plus b squared is the same as a squared plus b squared plus 2ab. And we want to minus 2ab. So this 2ab and this 2ab cancels out. So we just have a squared plus b squared is the area of the blue. However, the area of the blue is also equal to c squared. So this means that c squared is equal to a squared plus b squared. Okay? Now, let's go over some questions that use the Pythagorean theorem. Okay. A rectangle has a diagonal of 30 centimeters. So let's show a rectangle. Has a diagonal of 13 centimeters. Okay? One of its sides are 5 centimeters. What is the length of the other side? So look, we have a right angle triangle right here. Okay, I'm going to show you. Look at the blue right angle triangle. How do you find the length of the other side? Well, we know that a squared plus b squared equals to c squared. Okay? A squared plus b squared equals c squared. So let's fill in everything that we know. A squared is 25. plus, just like leave that as b squared, is equal to 13 squared. Now 13 squared is 169. Okay, now we can rearrange this equation by subtracting 25 from both sides. So that just leaves us with b squared is equal to 169 minus 25, which is just 144. So b squared is equal to 144. So if we take the square root of both sides, this just leaves us with b is equal to 12. So this is 12. Okay? Now, let's go over another question. A plane flies 3,000 kilometers east and then 4,000 kilometers north. Okay, so never ever. So we're here. It flies 3,000 kilometers east. 3,000. And then 4,000 kilometers north. 4,000. And we want to find this entire distance, because this is the starting point, this is the ending point. So we want to find this distance right here. Now again, we have a right angle triangle, and we can use the Pythagorean theorem. So a squared plus b squared is equal to c squared. So let's do this. 3,000 squared plus 4,000 squared is equal to c squared. And this is just equal to 25. 1, 2, 3. 1, 1, 2, 3. Right? Let me just write it out fully. 9, 1, 2, 3, 1, 2, 3, plus 16, 1, 2, 3, 1, 2, 3. Yep. Okay. So this is with 25 million. Now, we do this. So this is equal to c squared. So let's square root both sides. So c is just equal to 25 million square rooted. And that is the same as 5,000. So this distance is 5,000. Okay? And in fact, this is a scalar. Oh, sorry. This is a scalar of a 3, 4, 5 Pythagorean triplet. 3, 4, 5. And the reason we call this a Pythagorean triplet is because all side lengths are integers and they fit to form 3 squared plus 4 squared equals 5 squared. So all of these side lengths go along the right angle triangle. Okay? Now, let's look at the Pythagorean theorem in 3D. Okay? It might seem a bit complicated, however, I can break it down to make it a lot easier. Okay. 1 second, actually. Let me draw a... Okay. I have a right angle triangle. Sorry, I have a cube right here. And I want to find the long diagonal. Okay? So this is the top back right corner. I want to find the bottom front left corner. Okay? Notice that I could split this into this is the base. So this line right here is the base. And this is the height right here that we've already drawn. And that would form a 90 degrees. Okay? Think of it as a right angle triangle, but shifted 45 degrees, kind of, to match. So it goes along the diagonal. Okay? So now say this is, because it's a cube, this is, let this be 5, let this be 5. Okay? And it's also going to be 5. So what is the long length? So let's first find out the length of the base. And we can use Pythagorean theorem again to find the base, but using this 5 and this 5. So phi squared plus phi squared is equal to this length squared. I'll just label that as c squared. Sorry, I'll label that as c. So this is equal to c squared. So c squared is equal to 50. So c is equal to root 50. And this can also be written as 5 root 2. Okay? So c is equal to 5 root 2. Now that is the base of the tilted right angle triangle, and the height is 5. So we apply Pythagorean theorem again. 5 root 2 squared plus phi squared is equal to, let's label this long side as d, is equal to d squared. Okay? Now let's expand this out. This is 50 plus 25 is equal to 75. So d squared is equal to 75. Now we just square both sides. D is equal to root 75. And this is the same as 5 root 3. Okay? Now, if you want to look at the formula would just be d is equal to the square root of a squared plus b squared plus c squared. And this is exactly what we did in this case. But a, b, and c are 5, 5, and 5. Okay? The most difficult part about Pythagoras' theorem in 3D is visualizing the points and how this is still a right angle triangle, but just like tilted round. Okay? That will be it for the video. Thank you very much for watching.